Okay.
By golly, once again, we're doing it, gentlemen, on the 4th of July. It's three of the board members, anyway, of the South Coast Longtime Astrophysics and Telescope Club on the screen. Your Santa Barbara Astronomical Unit meets together online through Zoom every weekday or every Monday morning, our weekly SBAU Astro Hour. For about a year and a half now. Welcome aboard. It's viewable on YouTube, uploaded live every Monday morning, 11 a.m. And this is our 71st episode for July 4th, 2022 to the 10th. To watch replays of past programs or consider joining our incredible astronomy telescope club, go to sbau.org, everybody. This week, my name is Baron Heron. Anyway, I'm the vice president. I'll introduce you to two of the best friends I've ever had in the incredible club. Next, we're going to talk today about the 5 planets and the moon lined up before dawn, especially over the desert. Wait till you see the picture. Small asteroid is nearby, and a distant comet, which is way out there. One of the bigger ones, Pan-STARRS. The moon's crescent near Rho Ophiuchi. Got a lot of Ophiuchus to talk about today. And July 4th, just in time for Independence Day, a fireworks galaxy. We'll talk about that. Our return to Farron Hall is on Friday night, the 5th of August. Let's meet the president. White hair and all, and glasses, Jerry Wilson. Good morning. Captain.
Good morning.
PhD. Yeah, Captain PhD. Is it 3 or 4 seasons you and I have been in office here? Just curious.
I think it might even be 5. I don't know.
Well, it can't be that for me because I took over for the young man who went to Caltech on a scholarship.
Up to 4.
Weren't there 2 Adrians?
Yeah.
What happened to the other Adrian?
He's still around. He shows up occasionally.
Yeah.
Okay. Well, we need
We
some.
haven't been having regular meetings, so in-person meetings, so we can't tell if he's
All
still
right.
out.
Jerry Wilson sends us our material. He's married to the lovely Pat Torgey, also married to a Pat. Our merchandise manager is Chuck McPartlin, our outreach coordinator on the screen.
Good morning.
Possibly joining us anytime could be Tom Whittemore, editor of our newsletter every month. And possibly, if he's fully recovered, Mr. Bruce Murdoch, who happens to be the president of the Santa Barbara Theater Organ Society. We try to start with silly stuff, the silly science cartoons that Jerry Wilson comes up with. I've got the names of some of these, and I can talk about them if you want, my friend. What happened to the latest one that I thought was cute as hell? What do I do with it? I lose it? That's all right. Here, you bring it up and I'll comment. What gives people feelings of power? Well, money does, or some status, but really growing a tomato. I don't know how you came up with that because I got one, a little tomato plant, second year.
I spotted this because it turns out both my brother and my wife, and in honor of Tom Whittemore, who are avid tomato growers.
You do get a sense of power, I'm putting water in there, and I bought some Miracle Grow, and it's tough.
You'd be amazed about how much of nature eats growing tomatoes.
Yeah.
How much of nature? What tomatoes?
How much of nature eats growing tomatoes?
You also either love tomatoes or hate them.
Yeah.
And George Carlin had described that once. On the outside, it's just beautiful. It's round and red and glowing, but you cut it open and there's something wrong. There's something in an embryonic state inside. Anyway, call up another one and I'll see what we can do here to start our program with a good laugh, Jer. Since you have an endless supply of these things, I don't know where you get them, but get some. Kidnappers. I got this one down. Rejected. Kidnappers have abducted the young telescope freak, and finally, frustrated by the kid's constant descriptions of the cosmos, they return him home. We're sick of it.
It was an old movie back in the 30s, a black and white movie called The Ransom of Red Cloud. And it was these 2 grifters that went into a small town, and on the outskirts of the town, they kidnapped an 8-year-old boy. And then they sent a note in and they wanted ransom for the kid. And as the movie went on, they finally said, look, there's no ransom, just come and get him. And finally, they paid for someone to come and pick them up because no one would come and get them.
But it wasn't astronomy that the kid kept talking
No, it wasn't
about.
astronomy. It was just comedy.
What would they have been talking about back then? Discovering Pluto?
Oh, I think this even, yeah, about that time.
I guess so. You remember the Fuller Brush Man with Red Skelton?
Yeah.
That's one of the classics. Here we go. Which one is this? Proofreading. Couple of aliens have intercepted our long time in space Pioneer 10 probe and have checked it out for information about our culture and planet. One of them says to the other, "This plaque shows 9 planets, but their transmissions say their system has 8." To which the other extraterrestrial replies, "Well, maybe they haven't evolved the ability to proofread yet." I assume that's the space probe next to him, sitting there with it.
Yep.
Okay, that's not bad. That's not farsighted, is it? No. You're getting good, Gary, calling these things up. I had the other one written down, dang it. What did I do with it? It's got on the floor. Well, these are the 2 spiders. Need to relax, Charlie Brown. From the world of biology comes this: 2 spiders weaving their webs next to each other. And the one on the right seems to be kind of tense since his web turns out to be a stiff, solid grid pattern. Normal cobweb weaver says to him, "Hey, you really need to relax, Ralph. Come on." It's my story too. Clinically depressed, especially with the stock market going down, jagged. Any more?
One more.
Here it comes. Tell your friends we're on the 4th of July. Well, this, you're going to have to enlarge that because I had it written down and now I've lost it. But the astronomer dad is lying on the blanket with his 2 kids, and the one kid next to him says, "I think that's the Big Dipper, Dad." "Yep, also part of Ursa Major, the bear." "Well, that one looks like a big W." "Cassiopeia, the queen." "Oh, the curvy one, Dad, could be a snake." "Draco, the dragon." And the other kid goes, "Cool. What's the one that looks kind of like a butt crack?" That would be Al the plumber." The first kid grabs for the star chart and says, "Let me see that chart." Crying out.
My daughter loves baby blues.
Yeah. Next time we do a planetarium show, show us Al's butt crack. Al the plumber. Okay. What I'd like to do, since it's the 4th of July, gentlemen, and it's just us 3, is talk about and introduce the world to a galaxy that is just one big Independence Day fireworks show all the time. Let's start this with this. It's called NGC 6947, and it's known as the Starburst Galaxy. And I guess I have how far away it is. It's millions of light years distant.
Actually, Ron, starburst is a generic term. This one's the fireworks galaxy.
Okay, well, I have that word, that phrase, Starburst Galaxy, in his talking notes.
That's a generic term. This is a starburst galaxy, but its name is the fireworks galaxy.
Okay, my understanding was, as I mentioned to you earlier, most galaxies, including ours, have an average of 1 supernova every 100 years, right?
Well, you can't really say most galaxies, but our galaxy.
Okay.
Yeah, and we can only see a small portion of our galaxy here. We're not privy to the whole thing, what goes on in most of the galaxy. In M51, which is a very nice amateur object, there have been about 3 in the last 2 decades, I think, as I recall.
And M81 had some nice ones.
Yes, that's right. Yeah.
It's another starburst galaxy.
Well, some of those.
Go ahead.
Some of those novas light up the whole galaxy, that we can really see them, even though the galaxy is way far away, right?
Yes.
All right. This one has had 8 in the last 100 years. That means we've seen every one of them.
Yeah.
We would have had to see them to count them.
What's the plural?
So this is planetarium program on July 6th at 10 p.m. Cephas is high in the sky, and the Starburst Galaxy, now you got me doing it. The Fireworks Galaxy is at the center of this circle here. So NGC 946, that's the bullseye, that's where it's located. This is the Milky Way going through here, very nice section of the Milky Way. Cygnus the Swan, the long neck, the short tail. and the wings. There's the North American Nebula down here. And it's good to see a galaxy, more challenging to see a galaxy this close to the Milky Way is they're behind a bigger population of stars. And so we tend to see fewer galaxies in the Milky Way region.
And this one's really low surface brightness.
Yeah.
Really? And yet we're going to call it the fireworks galaxy? It's not putting on a show every night for people with...
It's not that it looks like fireworks. It's because of the number of... whoops, stop share.
Currently, it makes as many new stars as it loses them. But
well, it loses more because it makes more.
Yeah, but we're talking about really slow processes, aren't we? Do we see a new star just suddenly flame to life? And there's Tom Whittemore joining us.
New stars are not a sparkly event where all of a sudden someone threw a light switch. I guess it could be like that, but new stars come on inside of a stellar nursery. They're usually in a nebula when they form and turn on.
Okay, well, all galaxies like ours probably have clusters everywhere. Can you see clusters in distant galaxies?
Yep.
Yes. You can.
You can see in this one, you can see, let me make it just a teeny bit bigger. You can see all these red regions here. Those are hydrogen emission nebulas. And that's where stars are being born.
Using hydrogen.
Well, yeah, making out of hydrogen. Stars are basically hydrogen with a few impurities, even the ones that are high metallicity. So I can't spot any clusters by just by eye here looking at the picture, but these red regions are areas where stars will be born when they condense out of dust. And so there will be star formation going on there. There's a lot of red regions in this galaxy. There's a lot of star formation going on.
Red region. Red is hydrogen. Okay.
Hydrogen alpha.
You suppose we were formed in just such a region in the Milky Way?
Yep.
Okay. Is this
a project that identified a number of our sister stars that were formed in the same nebula that we were formed in.
So this is NGC 6947 we're looking at?
Yes.
This is it. It's a spiral, and we're looking at flat face on.
Yeah, which gives us a good look. When there's a supernova happens anywhere in the galaxy, we're looking face on. So we're very likely to see it. It would have to happen on the other side of some of these dense regions for us not to see it.
Well, not only see it, but take pictures of it. Wouldn't there be a shot of the nova going off and we see this big blast of fire and rim in the middle of everything? How long?
You'll see a bright star where there was none before.
Okay. Well, then what are the ones that totally go crazy and are as bright as the whole galaxy? Am I thinking of quasars?
Any one of those. Any one of those.
Any one of those could happen. But nobody's taken pictures of these 8?
Yeah, sure.
Yeah, that's how we see them.
Do they have them logged time-wise 100 years ago, like the early 1900s? Were we taking pictures through telescopes?
Sure.
From the 1800s, yeah.
Okay, Hubble had what, a plate, a piece of glass that he wrote on, for example?
Yeah, that was in the 1920s.
Well, that
100 years ago.
Yeah. Fascinating.
So we have surveys going on all the time. We have telescopes on Earth, wide field telescopes that take many pictures each night, looking for new stars to pop up. And we have satellites that do the same. They survey the sky looking for supernova. And when they catch one, there's the supernova center that sends out telegrams to everybody. So people with big instruments and spectroscopes can give up their time to something they hadn't planned on.
And they call the detection systems transient factories, and there are several of them.
Yeah.
Is this similar to booking the web? Good luck. Can't get on until 2047 or something.
No, there's a go ahead, Chuck.
I was going to say, they will preempt if there's something really important. They will bump you off.
Oh, they would. Hey, Tom Whittemore, editor of our
Morning.
newsletter.
Yeah.
Good morning. Have you been watching
Morning.
anything late at night on your scope?
Lots of stuff.
Okay.
So in the morning, Mercury still eludes me, but I see Venus coming up. I don't know, 440, something like that, 440. But I was looking for Mercury this morning. But lately, there was my August issue of Astronomy came. Just this is a little bit off the wall because you asked me if I were looking at things, and I'm pretty much a binocular astronomer right now. Have been for years. Phil Harrington wrote a fantastic article on the Bull of Poniatowski, which is now a demoted constellation. You know, 1930 was the year that basically IAU, the International Astronomical Union, designated 88 constellations and wrote up their, their borders and things like that. And there was this old, it's very special to me, and I'll tell you why. And if anybody could pull up the Bull of Poniatowski, I can make some comments about it. I don't have it on my machine, but if anybody could do that, Chuck.
I'll go call it up.
Okay, thanks, Chuck. So what I was going to say was that Phil Harrington writes these wonderful articles on binocular astronomy, which is kind of what I'm wed to right now. And in the August issue of Astronomy magazine, he talks about the upper sections of Ophiuchus, where this ancient constellation called the Bull of Poniatowski is now basically an asterism. It's now an asterism. It's special to me because, first of all, Poniatowski was a Polish king, but at the time when this constellation was drawn up in 1777, Poland's extremities went all the way down to Kiev, and also Poland ruled Lithuania. And it turns out the Lithuanian astronomer who basically put this little pattern up in the sky, the Bull of Poniatowski, was Lithuanian, and he worked out of Vilnius, which the Poles call Vilno, and that's where my grandparents were born. So you may know that I'm half Polish. My mom was entirely Polish because her parents came from Europe.
Okay, I'm going to try to share screen here.
Okay.
Yeah. Oh, thank you, Chuck. Thanks for doing. I'll just make a couple of comments on it. It's a beautiful, beautiful little asterism. Now it's called an asterism. But you see the bull up there. First of all, so Chuck is showing the entire Ophiuchus, okay, with the brightest star in Ophiuchus, Russell Hague, in this guy's eye. You can see it in his eye, okay. And Russell Hague technically means the head of the snake bearer, snake charmer, okay. And you see that little bull off his shoulder? So there are about 5 or 6 prominent stars in that little well, it's not a constellation, it's an asterism now. Okay, there are about 5 or 6 stars that kind of makes the summertime Taurus for us. Okay, we always have Taurus the bull in the winter. Okay, but now we have Poniatowski's bull in the summertime. It's an absolutely beautiful section of the sky. It's in some of the dusting of the Milky Way because it turns out that Scorpius lies below this constellation of Ophiuchus. And it's just wonderful in binoculars. And I recommend it to anybody who has, just a pair of binoculars. This is very, very easy to see with the skies darkening, I'd say about 9, just roughly 9 o'clock. It's high in the southeastern sky above Scorpius. And it's just a beautiful thing. There's also a lot of really wonderful open clusters up there, IC objects. 4665 comes to mind. All these things you can pull out of 42 millimeter binoculars. Just absolutely beautiful. So that's kind of, you guys, that's how I've been kind of spending my early evenings. Looking
and
at
Scutum there is also Polish.
Yes, yeah, the shield, right? Scutum is the shield. But yeah, if anybody gets Astronomy magazine or looks it up on the web, Phil Harrington's August write-up on binocular astronomy is absolutely fabulous. And it reminded me of the time when I was a little kid. My brother Paul was teaching me these constellations. But at that time, of course, it was an asterism. It was not a constellation. But there's the bull. There's the bull. So it's called Taurus Poniatowii. Okay. and real pretty. It does make a very spectacular V shape, okay? And a couple of the stars actually form the eyes, just like you have Aldebaran and Taurus the bull forming the big red eye of the bull. So anyway, that's my spiel. Thanks for bringing it up, Chuck.
No sweat.
Thank you.
They don't happen to sell a pair of strong binoculars that you can
No.
attach a camera to, do they?
Ron, I use my bird binoculars. They're really good. They're Vipers. They cost a pretty penny. They're not as expensive as Swarovskis, but they're 8x42. So they're 8 power, 42 millimeter front end.
And Ron, there are binoculars that have built-in cameras. Usually
There
it's like
are.
a webcam-ish thing that talks to a
It's
little.
And there are
yeah.
stabilized binoculars too, which is a big asset. So this is one thing you touched on is the planet alignment.
Yeah.
This
Thank you, Jerry.
is probably one of the last times we're going to see it like this. Mercury's going to start sliding off to becoming an evening object here about later this month, next week sometime.
But boy, has it been elusive, Jerry. If we have a pretty good horizon out there, but boy, it must be getting caught in the glow.
It's
Yeah.
it's heading toward Superior Conjunction. So
Okay. I
So
keep
this is a
trying.
picture taken from Egypt.
Yeah, I keep trying.
Western Egypt. There they
Yeah,
all
that's
are.
a beautiful image that Jerry pulled up.
Mhm.
So 20 minutes before sunrise, Mercury was supposed to be 4 degrees high and disappearing behind the sun. That's what the superior conjunction, and that'll be July 6th.
Yeah, it's tough, Ron. It's real tough right now. And I look and I look and I look. And I just happened to be up at 1 a.m. and I did about 1 a.m. or so. And I did see Jupiter just high in the east. Okay. Really
Wow.
nice.
And
I
that's
think
the-
Saturn is just becoming an evening object.
Yeah.
Comes up now before midnight.
Mm-hmm.
It's still not very high up until the morning hours.
and
Yeah.
coming up in a couple of weeks is Titan is going to occult a star. And so there's a campaign to watch the occultation and try to measure the atmosphere and the wind speeds in Titan's atmosphere based on the occultation.
Wow.
Is Titan viewable around Saturn just like the 4 Galilean moons are around Jupiter?
Yes.
You can.
It is about the easiest one to see around Saturn.
Okay.
Now, this
Wow.
particular picture is set for, this is also from a planetarium thing, for July 6th at 2 a.m.
Okay.
There we are. There they are.
So that's Wednesday morning at 2 a.m.
Cassini territory. Cassini.
Yes.
What is supposed was left of Cassini? Nothing?
Not much.
Mm.
All its elements. If you remember how the planets were lined up, or if you want to call it up again, or just remember, is that the ecliptic? Are we at an angle of the ecliptic? The sun's ecliptic. It's what it said in your notes. The 4 planets that were, if you drew a line through them, it's an angle. It looks like about 45 degrees with the horizon.
Don't forget Saturn up here.
Yeah.
Yeah, well, that's on the line too.
Yeah,
Okay,
that is a representation of the ecliptic.
So we're angled at the ecliptic because we're so high up on the northern
That's because the
hemisphere.
Earth is tilted.
If we were on the equator, would it be 90 degrees or
No,
flat?
no,
No,
It's
it
the
would look
same
just like
everywhere.
this.
Okay, interesting.
Can you guess from this picture what the tilt of our axis is?
Well, I happen to know it's 23 degrees, isn't it?
You're right on, within half a degree.
And it wobbles over the centuries, supposedly. That's kind of scary.
Yeah.
Yeah,
one
be careful with those terms. It's actually precession.
Yeah. One of the problems right now, Ron, also with trying to get Mercury in the glow and everything is that the ecliptic in the morning, remember the ecliptic is the plane that contains the Earth and the sun. It is very shallow. So it makes fairly shallow angle in the morning sky. And so Mercury doesn't get all that high above the horizon. Okay.
Even when it's far from the sun, it doesn't get high above our horizon.
Right. That's right. Yeah.
Well,
Sometimes we get these spectacular, what they call apparitions, Ron, where the ecliptic is highly, highly angled. And so a distance away from the sun from our viewpoint is also a good distance above the horizon.
And that would be autumn or spring.
That's correct. That's right. That's right. Mm-hmm.
and I believe I asked this question about Venus, and you told me an answer. I'm not exactly sure, but if one of the inner planets is on our side, we get a crescent. Is that crescent view any brighter than the full view on the other side of the sun?
Much brighter.
Much brighter.
Even
Yeah,
though
the
it's
whole
only,
thing about Ron, the whole thing about Galileo, when he was drawing these things, especially of Venus, he saw that Venus was larger as a crescent than it was as a big moon-like thing. So he knew the sun was the center of the activity. He really knew it.
Yeah, it's not only does it appear much larger, but the distance is, 1/r² for the light. So that adds to it too.
Right, right.
Even when only a thin crescent of it is illuminated, it's much, much, much brighter.
well, one of them, either Pluto or Mercury, is smaller than our moon, isn't it?
Pluto is. Mercury is about 1.5 times the size of our moon.
Oh, is it? Okay.
Yeah.
And it has no atmosphere.
So
Very
speaking
little.
of Pluto, I was just going to mention in the August issue of Astronomy, there's a nice article written by a fellow who tries to image Pluto the same way that Clyde Tombaugh did in the 30s. It's pretty interesting. I think it was a lot of work.
Yeah.
So, because I think Pluto right now is about magnitude 19 or something. I mean, it's awfully dim, and I've only seen it in a 61-incher in Tucson. So I've never seen it in my telescope at home.
Well, gentlemen, we're halfway through the program, and we want to get into asteroids, but before the thing goes away, Pan-STARRS is on the horizon. Is there some way, Jerry, you can call up that picture, one of our members, Mike?
Yeah, Mike Chibney.
Yeah, let me just,
And then I'll give you what I have on, let's see, where is it?
By the way, Ron, guess where Pan-STARRS is? It's in Ophiuchus.
Everything goes to the Ophiuchus.
Ophiuchus is where it's happening.
Yeah.
I guess I grew up never hearing about it. It's also known as C2017, C/210, 2017. I assume the year it was 2017 was the year it was discovered. K2 got imaged a couple weeks ago on June 20th, but that's not the picture we were showing you. This was our guy, right, Mike?
Yeah, this is a
It's
couple
Mike.
of nights ago.
Yeah, Mike Chibney. Mm-hmm.
I got to tell you, anytime in my life I've seen a comet, that's what it looks like. I rarely see the tail.
You can see the tail here going off to the left.
What is it? Say it again, gentlemen.
There's a tail going off to the left there.
I guess I can, yeah, okay, but you can't see that with the naked eye. In fact, you wouldn't be able to even see it without a telescope, right?
Nucleus, coma, tail.
Yeah, it's right on the verge of naked eye visibility from a really dark site. It's like magnitude 7.2 right now.
But also the tail is pointing almost directly away from us.
Yeah.
So it's very foreshortened.
And Ron, you can see that Mike's tracking the comet, so the stars look smeary,
Tracking, so he's moving with the comet, which is moving a little
That's
bit.
what it seems like to me, right, Chuck?
Yeah.
Well,
Yeah.
what he did was he took pictures. He took multiple images, but then in the stacking program, he tracked on the nucleus of the comet. So in effect, he didn't have to track with his telescope, but he's tracking with the images.
I got it. Okay, I see.
So you can
Same
see how
difference.
there's some boundaries up near the top. You can see where there's some boundaries where the entire image shifted.
Oh,
Yeah.
yeah. Oh, yeah. Mm-hmm. And so those are called star trails, Ron.
Yep. Let me show you, let's see.
2.4 billion kilometers from the sun, which makes it about 1.5 billion miles. Out past, let's see, in December it'll reach the sun. It hasn't come past, it's between Saturn and Uranus, coming from the Oort cloud. This
Yeah,
direction.
this is a first time comet to the.
And it's a big one too, right? It's 13 miles across.
Yeah.
Decent
So anyway,
size.
this is when it was passing about a week ago or 2 weeks ago, when it was passing by the star cluster IC 6554, I think it was. open cluster, and you see the tail is on the right side of the comet. In Mike's picture taken a few days ago, it's on the left side. The comet has passed through, pointing directly away from us.
Yeah. Just going to mention, Jerry, that one of the beautiful open clusters, that's going to be near where this image was taken, up in Ophiuchus, is 4665. It's really evident in binoculars. It's really pretty. Okay, nice open cluster.
Well, if it's that far out, it's kind of cold out there, isn't it? How would it get enough sunlight to make all that steam come off and make a tail?
Doesn't take much.
Doesn't take much, huh?
Yeah.
And yet
That is, I think that is 4665 there.
Yeah.
Oh, because you can
What
see
did I
that
say?
in binoculars real easily. It's really pretty.
I don't know what you said, Jerry, but when Tom mentioned that, I just went and looked at the caption for the picture, and that was it.
Yeah, it is IC 4665.
Gosh, I could have seen it with binoculars and I didn't know about it.
Yeah.
am I the only one that has the 2001 monolith on my screen?
No, I've got one.
Okay.
It's singing to me.
Here we go.
Are you back to regular? Sorry.
Yeah.
Isn't that pretty?
Fascinating stuff. Good old pan stars.
That's a busy section of the sky. The upper section of Ophiuchus is really pretty, real dusty.
And you can get a hint of that from some of the sort of reddish brown you see in the upper part of this image.
Yeah. Hey, Chuck, do you think that's Sebelrai down there on the left?
Could well be.
Yeah. I just found out what that means.
What?
The heart of the shepherd.
Ah.
So somebody must have thought of this constellation, because there's shepherd's dogs up there that nobody talks about anymore. Must have seen it as some sort of a shepherd. Yeah. I think Sebelrai used to be called Caleb, Cheleb. Caleb. I've been kind of into Ophiuchus lately.
Well, do any of you gentlemen remember a recent story about some space agency? It might have been ESA that was looking for a comet to go visit because somehow the one they had planned didn't work out. Am I just imagining that, or did I read that?
Well, the Rosetta, or I think one of the missions they've repurposed now to they're just waiting for a comet to come, and then they're going to try to go out and image it.
Why not pan stars?
Well, the trajectory is probably not good because the spacecraft has limited fuel, so they have to kind of. They're probably betting on one that's in the plane of the solar system. This one is coming from far, I guess you'd call far north.
Yeah. So it's
just another added thing here is that if that is 4665, that's about 1,100 light years from us.
Mm-hmm.
So that comet is way in the foreground.
Oh yeah, no question.
So my understanding is the Oort cloud, unlike the Kuiper Belt, all the planets is a shell. Mm-hmm. It's not part of the ecliptic. It's not like an ecliptic, right? So if these suckers come in from the Oort cloud, they could come in any direction, just like Oumuamua did.
Right.
Yes.
And in other words, that may not be on the ecliptic right now, right?
It is not. It is coming in from the far north.
Okay, but goes around the sun and then goes away, and all of them have different directions, Halley's.
That was the first hint that there was an Oort cloud, was seeing these comets like that.
Oh, okay.
And Chuck, this one's not returning, right? Pan stars?
Not anytime real soon, no. But it's not escaping the solar system. It's not on a hyperbolic trajectory.
Okay.
Okay, what is this you're calling up, Mr. President?
Well, as long as we're in Ophiuchus.
Yeah.
This is a complex around Rho Ophiuchus near Sagittarius. You can see all these Barnard Nebula, the dark nebula, that are not being illuminated, but they're blocking light from star clouds on the other side of them.
And that's Antares at the bottom.
Yeah. And this is
M4.
That must be 4.
Yeah.
Which you can easily see in binoculars in our backyard.
The globular star cluster. In binoculars, it looks like a fuzzy star.
It's called a cat's eye globular because it's got that linear feature up and down near where your arrow is, where your cursor is.
Oh yeah, it does, doesn't it? Like a cat's pupil.
Yeah.
Huh. I never noticed that before. The this is a very colorful region of the sky to photograph. It's very dramatic, and it's very big. This would be is what you can get with just simply a camera lens. You don't need a gigantic telescope. As a matter of fact, to get all these features in one field, you don't want to go with a high magnification at all. It's for us, it's way in the south or the southern horizon, but it's well high enough for us. If you're at a dark site, say up at the gun club, it's great to take pictures of that.
Mm-hmm.
Huh. Is that Rho Ophiuchi we're looking
Yes.
at?
Yeah.
Up top. The
What?
multiple star.
Okay, well, the notes gave us crescent moon is near Rho, RHO, Ophiuchi.
It's a
Okay,
Greek letter.
Right.
serpent bearer. 4 degrees wide. Wow, the region is anyway.
It's a neat part of the sky, Ron. It's just absolutely beautiful.
And one hint that it might have been a camera that took this picture is the camera lens diaphragm give you those diffraction spikes on the stars.
Yeah. Yeah.
Right. That's how many facets there are on the aperture.
Mhm.
You suppose any of the stars are binaries?
Oh,
look,
yeah.
Ron, look how
It's-
many of them are. Yeah.
Yeah.
Rho is a triple star system there visually.
hmm
But they blend together to look like one big star.
No, up top. You can see there's 3 there.
3 stars.
1, 2, 3.
Oh, damn, okay. More than half the stars in the skies are doubles or triples, aren't they?
Hmm.
Wow. Fantastic.
Yeah, it's a beautiful region.
Oh,
Our guest speaker on Friday night, Dr. Zellum from JPL and NASA, was telling me, what was my question? It was about exoplanets and exactly how they're going to find them in the future. And they're going to send, I guess Webb is going to do that right away, wouldn't you say? When they open it up in about a week. We all
Well, their emphasis is looking deep. So that might not be the first thing they start doing, but they are going to try to look at some exoplanet atmospheres.
You suppose Webb is working right now? We just don't.
Oh, absolutely.
Okay, they're using it, and then they're going to show us the best stuff. How long does it take a radio signal? About 6 seconds to get to Webb and come back?
It's 1 million miles, so take 1/93 of 8 minutes.
about 8.
Well, it's about a second and a half to get to the moon, which is a quarter of the way.
Okay, yeah, so that's right.
About 6 seconds. You want to talk asteroids? Because you said an addendum after the fact. I got it last minute, and there's a lot to learn about asteroids. Like Ceres is a dwarf planet, but there's a new name for all the rest of them, all the rocks. And,
Yep.
Name? What's the new name?
Minor planets.
Oh, that's not new.
Well, it's new to me.
That's
can't-
what happened. Run. When they first found Ceres, they said new planet, and then Pallas, new planet, Juno, new planet, Vesta, new planet. And by the early 1800s, there were like 16 or 18 planets in our solar system. Okay. And then they got photography and they said, oh man, these things are like rats. They're all over the place. And so they demoted them and they called them minor planets. It's the same thing that happened to Pluto, just happened 200 years ago.
Because when they discovered them, they were just pinpoints of light. They were just, you couldn't resolve them.
And it was actually Herschel who said we should, instead of calling them planets, we should call them asteroids. They look like stars. That's what asteroids mean.
Okay, so they're not
So
called
let's-
minor planets anymore.
Let's
Right.
turn our attention to Ophiuchus for a change. Here's in this region out here is the asteroid for the month 387 Aquitania.
Yep. All numbered as when they were discovered. So this is not one of the brighter ones.
It's not brighter, no, it's one of the higher number ones, but it's not very high. The I'll let you guys discuss the asteroid thing I've got there.
It's not, and the number, Ron, is not just when they're discovered, but it's when they determine a good orbit for it. So you'll see a bunch of the newer ones that, you know, when they first find them, they'll be calling them 2017 AQM or something like that, because they have a system that lets you identify what part of the year they were found in. And they don't get a number until they get an orbit determined for them.
Well, I learned from Jerry's notes that the asteroid belt, as wide and thick as it is what, 2 to 4 asteroid units or 4 to 6?
Astronomical units?
Yeah, I think it's 4 to 6, isn't it? Away from the sun.
No,
We're one.
because Jupiter's at 5, so it's more like 2 to 4.
Mhm.
Oh. Well, then
That's the main, that's where most of them are. So far, there's been over 2 million asteroids spotted.
So is Mars another astro unit from us? Another 90-something million miles, you suppose?
It's 1.5 at least, or something like that. Or 2.5.
Yeah.
Okay.
Yeah.
And Aquitania, I wonder what they, this is one that comes into the sun like a comet?
No.
I got that impression from his notes. It's close to the sun, it says.
Well, it's at its perihelion.
Closer than Earth. So it has a strange oblong orbit. That's what you're saying.
It's not a near Earth asteroid.
Yeah.
Okay, but if it's closer to the sun than we are, that makes
No,
it.
it isn't. It's just at its closest point to the sun.
Yeah.
Oh, okay, then I misunderstood. Okay, it's less than it's magnitude 7. Oh, that's a globular cluster that is just east of a globular cluster out there, M14 in Ophiuchus. There you go. Just over the border in Serpens Cauda.
Cauda.
The tail of the snake.
Right.
Serpens Cauda. It means tail.
Not to beat to death this whole thing about the bull, but if you look to the left and below Sebelrai, okay, there's the bull. There's the bull. You see the little kind of like V shape. That's the bull.
Like a triangle there.
Mm-hmm, mm-hmm. His nose is that last star, Chuck, in that triangle. And his 2 eyes come out left, right.
Yeah.
There is.
And you can see little horns too.
Yeah,
coming up above. So if you come down and left from where it says Barnard's star, that's like the V that makes the face of this.
That's exactly it.
Poniatowski's bull.
Yeah.
Well, that bull has special meaning.
In that article, Phil Harrington was trying to get the rest of the bull up there. And he says, I give up. So he just about those 5 or 6 stars there that make that nice V.
Well, there's Rassel-Gethy up there, which was the eye.
Mm-hmm.
No. Rassel-Hague was the eye. Rassel-Gethy is the head of Hercules.
Right. It's the head of the kneeler, technically, right?
Okay.
Kneeling Hercules. Took me a long time to figure out that he was kneeling.
Yeah.
I thought his head was on the other side for years. That his
this is a very rich area.
Very what?
Rich.
Well, I thought Tom was through talking, but his voice just cut out for a while. I didn't mean to shut him off. Go ahead, Tom.
No, I think we're good.
Okay.
The bull has special meaning to me because that's my sign. I was born April
Well,
21st.
this has nothing to do with that. That's Taurus, which is another part of the sky.
Oh, it's a
winter
different.
constellation.
You're looking at a different bull. Is that what you're telling
Yeah,
me?
this is the
Yeah.
bull of Poniatowski that we were talking about first thing.
Right.
I saw the
It's
pic. Okay.
It's not a constellation, it's an asterism.
Right. And Ron, your sign is Taurus, right?
Yep.
So you can see your sign if you get up about 3:30 of this morning, tomorrow morning.
Oh, I hear nothing but bull stuff, Yes, but
You've been on the internet, huh?
I never hear much about Aries. What is Aries?
The ram. Golden fleece.
Yep.
Oh, ram is Aries. Okay. Well, I know our Tom Totten was born on summer solstice a couple of Mondays ago, and that means he was probably conceived on fall equinox.
Okay, well, that's biology. So back to this. This is a very rich region of the Milky Way. You can see all the Messier objects, Messier 11, 26, 16, down here south of Serpens in the southern part, M23, and of course the globular cluster here, M14. This is also a globular cluster.
And 10 and 12. Yeah, it's like globular cluster central.
Right.
Yeah. And here is Scorpius,
Mhm.
and I don't see Zubenel Ganubi and Zubanesh Shamali, but they're in this region.
They're off to the right.
I think they're to the right, Jerry.
They're off to the right. Yeah, there you go.
Oh yeah, there they are. Yeah.
They would be the claws of the scorpion. They used to be.
Now, these are one of the earliest star names that I ever remember, because during a planetarium show at Griffith Observatory, my family used to go every month to the new show down there when I was a child in the 1950s. And the speaker was talking about, he got a phone call from someone in the community that wanted to name their children twins after give them star names that sounded so pretty. And so he recommended Zubenel Shamali and Zubanesh Shamali and Zubenel Ganubi to them. It was quite unexpected, but it fixed those names in my brain.
Yeah,
That's pretty good. Yeah, Zubin, of course, is claw, right? And one's north, south. Yeah.
Huh. They didn't start out as somebody's names in the ancient times?
no, they come from Arabic phrases for the claws of the scorpion, northern and southern claws.
Mhm.
Now, the only one that has a real person's name to it is right here in the middle.
Okay, that would be,
Barnard star.
Barnard's-
who was
That's it.
Barnard?
There may be other ones, but that's the only named one I know that has a person's name.
Yeah. But Barnard was an astronomer in the late 1800s, early 1900s, who worked at Lick, primarily at Lick Observatory.
And he's well known for describing dark regions.
Yeah, this great rift where the Milky Way is missing is not missing stars. That's a dark nebula, cloud of non-illuminated and non-emitting gas and dust that's in front of the star cloud. And this is, he made a catalog of these dark nebulas. So the dark nebulas have numbers, B something or other for Barnard. And he put together beautiful limited edition photographs of a star atlas of those things with original photographs in each one back about 1920 or something. They don't get a lot of talk because they're hard to see.
Right.
So,
Yeah, Joe likes those a lot, Joe Doyle.
Yeah.
He likes some of those objects.
We were just up at Pinos this week, and there were people looking, the whole crowd that was there, they were looking at stuff like that,
Uh-huh.
including the fireworks galaxy.
Wow.
well, tonight there'll be a lot of fireworks galaxies around here.
Yeah.
A lot of missing dogs tomorrow. It's interesting to me that we're looking at the side view at an angle with all those clouds and dust of our Milky Way, and yet all the stars fill the sky. They seem to be outside of it. But is that because we're out here in an arm extended from that mass that bisects our sky?
Yeah, and they're around us. We're embedded in the arm.
Right.
We're not in an actual arm, because then it would be a little more crowded. We're kind of in the
The
little
spur.
bit of stuff in between. Yeah.
Yeah,
Orion
the
spur.
they call it.
Well, it'd be fair to say that every star we see is part of the Milky Way. We certainly don't
Yes.
see anything
That
outside.
is true,
Yes.
yes. Except for supernova.
Now what do we got here? Is that the Edge-on galaxy, NGC 5866?
Yes.
I'd have to look at my notes to see what number it is.
I think it is. It's thin
Yeah.
and long. Dusty part is
Yes.
20 times longer than its thick center. Its stars extend out even further.
Wow.
But you can see the same effect here. If you look at the galaxy, the edge on here, we see dark clouds. These would be Barnard nebulae. And we can see other nebulae that are illuminated. And it blocks most of the star clouds in here. So these would be regions where you could get gas and dust to form stars. The stars actually themselves go out farther on the disk, and they form this halo. This is an unusual galaxy in that it's flat like a spiral galaxy, but if you looked at it straight on, it would be almost featureless. It would be like it's called a lenticular galaxy. So it's a special type. But it illustrates the blockage of star clouds in a galaxy. Now, we're edge on in our own galaxy. We're out near the rim of the galaxy. So in Star Wars terminology, we're a rim world. So,
And this is actually also M102. So it's easily visible in a small telescope.
you mean, oh, this is M102?
Yeah, it's at 5866.
Okay.
Messier's 102nd
Yeah.
discovery. In the
And
sky.
it's the dust lane is really prominent.
Yeah. You can see other galaxies in the background. There's a galaxy there.
Huh.
And it looks like there's some spiral or galaxies way back there and another lenticular galaxy there.
Galaxies don't line up. How about the local group? Are we all pretty much the same as far as face on or edge on? Apparently, just like stars, all the ecliptics are turned every which way, aren't they?
Yeah, they're not ecliptics because that's where the sun goes, but they're
Yeah.
they're
Ecliptic is-
equatorial planes, if you
Right.
think.
Equatorial plane. All right, same thing. But and we're looking at this one side on, and we can see. Wow, looks like it has a center.
Uh-huh.
How are we doing on time, gentlemen?
About 8 minutes.
Good.
First quarter moon is midweek. Did you want to talk more about that extra stuff you sent? There's the moon. You did send some more stuff about asteroids, but maybe we'll save that for next
We
week.
kind of covered that.
Yeah.
We talked a little bit about it, and then the other stuff I sent was Mike's picture of Pan stars.
Okay, that's
So
where the
this
moon.
is right now. The moon is a crescent. Last night it was a beautiful crescent. This is what it will look like later this week at first quarter. It's one of the best times to look at the moon. It doesn't blind you if you're looking at it with one of our big fast Dobsonians. And the Terminator shows a lot of features right down the middle of the moon. So at this point, when I was young, I liked to photograph these craters in set, especially this one. I think this is Ptolemaeus. And you can, right about this time, you can see shadows on the floor of it that show that it's rippled and bumpy and
What's up?
has collapsed regions in it.
And there's a great webpage at NASA Goddard Space Flight Center called something like the NASA Visualization Studios, where you can go and enter a day and date, and it'll show you an image like this of what the moon is going to look like. Very realistic.
Does science know why there are no Maris on the dark side? They're all on our lit up side.
Well, wait, it's not a dark side, it's a far side.
Far side, you're right.
Yeah.
It's lit up, but we can't see it on certain times. I understand that, but supposedly there's no mares or Maris or whatever.
There are a couple, they're much smaller.
Oh,
and
they
the
are.
crust is much thicker there.
Yeah.
And we think it's because there were a couple of moons, at least two, and the smaller one collided with the current, what is now the current moon, and sort of coated that part with a thicker crust.
I saw a video that was titled "Why NASA Will Not Land on the Poles, the North and South Pole of the Moon," and I didn't open it up. But have you heard anything about that? That's where the ice is.
That's where everybody's going to be very shortly. There's no reason to not go there.
I should have opened it up and seen what they had to say.
It probably would have said that it was where the openings were for the Nazi submarine base.
You know, they need a crater on the backside named Larson on the far side of the moon.
Well, if ice can form and be on the poles, it can't be on the face that faces the sun because
outright on the surface unprotected, it'd sublime away.
It gets that warm that it would steam away as
Yeah, it gets 200 degrees in the sunlight on the moon.
Does it really?
That's why the astronauts had to wear suits that piped water throughout the suit, because the side that was in shadow was at minus 100 and the side that was in sunlight was at plus 200, and you had to distribute the heat around.
Mm-hmm. Yeah, do you either have a suit cooling system or you had to turn around all the time?
Wow. I wonder if someday they'll point Webb at the Tranquility base and try to call up Apollo 11 They won't do that, you know.
This would be way too bright an object. It would overload and it would waste time.
The Lunar
Really?
Reconnaissance Orbiter has great pictures, even of the footprints of the astronauts,
Yeah.
foot trails.
Really?
Yeah.
But none of our Earth-based telescopes could possibly see any of those landers on the moon.
No.
No, and our Earth-based satellites can't either. The one Chuck is referring to is orbiting the moon.
And
Okay.
you can see the Apollo 11 landing site in this image. If you take the Sea of Tranquility there, you know, it looks like a soccer player. There's a Mare Crisium in the upper right is like a soccer ball, and then you've got his head and his arm and his torso.
I see it now.
And if
Yep.
you go right about where his elbow might be, or between his elbow and his shoulder, you can see a feature that looks like a fish with a Pac-Man mouth grabbing a little cookie.
Good
Well,
Lord.
you're
Oh,
getting,
so come up, Jerry, with your cursor. Up a little more, up and left. Oh, I'm sorry. I'm looking at my cursor. Down, down, down. Down, down, down. Okay, down. Oh, now up a little. Okay, and a little to the left. Now down. Okay, and now a little to the right of that, you can see a feature right to the left of Jerry's hand that looks like a fish grabbing a little cookie right on the edge of the Mars. Yes,
Oh, yeah.
it's right there, right now.
there's the fin.
There's the fin and a Pac-Man mouth, and he's grabbing a little cookie.
Yeah.
That cookie is a crater called Moltke, and Apollo 11 landed right near that.
Okay.
But did they scatter all the other live landings around those Mares?
Yeah. There was
Okay.
only one that was in a highland region because they were worried about boulders.
Sure, but they managed to, I recall seeing some hills, dust-covered hills, but so that's what you just showed us, the fish eating the cookie is where Apollo 11 landed,
Yes.
kicking up some of the,
That's not a feature you'd see from the surface of the moon. That's just our spotting feature.
Yeah.
I have trouble finding the man in the moon sometimes. So
well, do you remember the scene in 2001 Space Odyssey when the big bulbous spaceship is landing from Earth and it's kicking up dust that's billowing up like clouds
yeah,
as it landed? I noticed that, and I have a feeling that Neil deGrasse Tyson is panned. That's one of the few mistakes Mr. Kubrick made.
It's a mistake about it.
now they were landing in Clavius, which I think is this.
Down there, is that
It's
clear?
in this region, and this might be it, or this might be it.
Huh.
Yeah. Why would there be something wrong with that, Ron?
Well, because we saw the dust that Neil was kicking up as he was landing, and it was just going straight out. But inside this area, that remember that big flower-like thing that opened up and allowed it to land inside, and it still there was no atmosphere, so it wouldn't billow up like clouds.
Well, if you've got rockets going, you've got exhaust, and they would billow it out like clouds.
Would they?
Yeah.
Okay.
In fact, when Apollo 11 took off, it blew over the flag that they planted.
Well, I didn't know that. Wow. Amazing. Clavius is where they land in the 2001 movie?
Yes.
That's where they landed in other places, but that's where the monolith was buried in Clavius.
That's straight from Arthur C. Clarke's book, huh?
Yeah, it's a spectacular crater, Ron. It has like an arc of like 5 internal craters.
Mhm.
It's a fun one to show when the moon is about, eight days old, maybe something like that, maybe 9 days.
Wow. And
Right after first quarter, it's a great crater.
Yes, right. Mhm.
But the reason this form of the moon, half full, I assume, is so good for astronomers with scopes is that you see the shadows, right?
Mhm.
Yeah.
Mhm.
Shows all the structure.
Very 3D effect.
Yeah.
But you also see them pretty good with a brand new moon, right? A crescent, thin crescent.
Yeah.
Mhm.
Anytime you have a terminator, you're going to see detail along the terminator.
Yeah.
Right.
But here you've
Oh,
got sort of more territory that shows that effect than at a thin crescent.
I got you. Fascinating. Does the Elon Musk tell the world where he wants to land?
I think he's working on where he wants to take off from right now.
Yeah.
Oh.
Still trying to get approval to launch his Starship.
The sooner he goes somewhere, the better off we'll be.
Yeah, right. Well, I think we've run out of time, gentlemen, but happy 4th of July. And
Yeah, happy 4th, guys.
I'm
Yeah.
sure you've got your barbecue stoked up and your high-priced meat ready to cook, and I'll be over in a minute. Just tell me. Family, we'll talk again next week. I hope to be on board, but if I'm not, you'll have to handle it without me. I think you'll do great. I may be watching it in Pittsburgh, but I'll talk about that when we get back. Thank you, Tom.
All right.
And Jerry and Chuck, take care of your wives and your lives. Don't get COVID.
Happy 4th of July. Be safe.